10 degrees.
10 degrees.
Yep.
I can just push sine 10.
Yeah, yeah. That's how this calculator works.
Sweet.
It's doing a spirit level.
Spirit level.
Yeah, we try to get the water
Roughly equal.
Same level at one point.
Okay.
All right, we're at 28.
All right, 190, 28. All right. As you move up, you just continue to take that difference, add to that difference to that difference, and that gives you the total.
Perfect.
You mean this reservoir? I know it could be like 5 gallons instead of like 2 quarts or whatever.
Did you guys need to do anything to get the pump going?
Just push it once.
So anybody has an information? Where do you have the water pump? Have you electricity? Just a super.
Alright, go for it. I got you. I got you. Move further. So we did one section then, or
Yeah, so like if we mark that string off, so that would be our first measurement, and the second measurement would be section 2, section 3, so on.
right? Okay.
So then the area is really the area of
Inside
that.
there.
Yeah.
Okay.
Yeah. So I think our first one's probably 0, so when like 0 to 15, 15 to 30, 30 to 25 or whatever.
And I is the 30 centimeters.
Or the,
Yeah,
yeah.
each
Yeah.
was 30. Yeah.
Right. See the pattern.
Should we do the pressure, like to close the...
Right.
It's all good though. You're thinking under pressure.
Organization, you know, I mean,
Step back and you can give me opinions on the general class today and the last couple of days and see what you learned, what you would recommend doing different. So if we start with numbers, let's see. I don't even know if everybody who measured heights, altitudes, if they, I think everybody started from the same point, but I don't know if they finished at the same point. So let's see. We should have at least 8 different measurements done with 2 different methods. So who wants to give me what height difference they got?
Okay. We got 37 feet with the altimeter, the inclinometer.
Oh, the inclinometer. How much? 47 feet?
37.
37. Were you measuring the same? What were you measuring?
Oh, I think, I'm not sure if we were measuring the same place or not, but we got, so we did the same measurement with the water, we got 23 feet.
Wow.
So we didn't get the same answer for those two either, yeah.
Huh. Okay. Tell us what you saw
All ramp
and what you did. Well, to fry the meter.
what we did to fry the meter. You create a short circuit inside the box.
Basically,
Well, it's
you measured a short at the battery
Right,
terminals.
right, yeah.
That would
Which
be
is really easy to do when you're doing this, you know, trying to figure out how to make it work.
So the good thing is the battery didn't blow up.
The battery did not blow up. That's messy.
But you said the wires were really hot.
Oh, we got the wires.
We got a
out.
puff of smoke and hot wires and sparks and all sorts of good stuff. But in terms of the performance, we didn't. I mean, we raised the pipe up 8 feet, and only then did we see it starting to drop off. Otherwise, the pump performed pretty steady, didn't it?
About the whole thing, I think, is that there was not enough sun, and we were too deep inside the woods to get any juice out of the solar panel, because that would have been interesting to try and see what happens if you feed different angles. But well, okay. So now it'd been good to have some kind of input or brainstorming. Why? So. What was the main observation? I mean, qualitatively, what happened when you had the pump running and then you changed the height, the delivery height at the end of the tube?
Amps dropped.
Amps dropping. So, in theory, if you look at the water side, you raise the same amount of water. Well, we didn't measure how much water was going through, so maybe that's an issue.
Yeah, definitely the water went down.
But if we assume that it's the same flow rate, if you keep the same flow rate and you increase the height, hydraulically it's used more power. So if it uses less amps, there's something weird somewhere, which would, the only way to interpret that would be that you're hitting some weird efficiency curve in the system. But I guess the other way to rest in peace with this thing is to assume that the flow rate was changing so much that on average it balanced out. So that means there was really one key variable that we didn't measure, and that was the flow rate.
Well,
and trying to get as many sustainable technologies shown up in this area as possible. So the toilet, different kinds of heating and cooking. We don't have super great rainwater systems up yet, but we're working on that. And then we applied for a Green Investment Fund grant for an education building, which is going to go down there and so, trying to be a net zero